Stretchy, come on. Sorry. Hi, I'm Stretchy. Bleep, bleep. Today, we are going to be learning about a very special shape called a parallelogram. A parallel of what now? A parallelogram. It's a special kind of quadrilateral that has both pairs of opposite sides parallel, as shown by these arrows. There is also the height of a parallelogram that appears to be the height of a right triangle fitting inside it. But sometimes, the height of a parallelogram could also appear somewhere else, like over here, making another triangle a right triangle instead, like this smaller one. Or, if we concentrate enough, we could make another right triangle over there. This makes a big triangle. But what is very interesting about parallelograms is that although their heights are all perpendicular, they vary from short to long, or from short to tall. They vary. What? They're different heights? Yes. The height of a parallelogram is a line segment that is perpendicular to the base, which means that the height could either be short or tall depending on the type of parallelogram. Let's see how tall the height of the green parallelogram is. Let me use my yellow tongue. I love to use it. Ooh, this is interesting. The height of the green parallelogram is roughly as long as Stretchy's yellow tongue. Interesting! Yes. But what about the blue parallelogram? Let's see. Yeah. Come on. Stretch out. Stretch. Here we go. What? The blue parallelogram's height is taller than Stretchy's yellow tongue. Wow! Looks like this parallelogram is very tall. But what about the yellow parallelogram? Okay, this is perfect. Yellow tongue, yellow parallelogram time. Ooh, this is something new. The height of the yellow parallelogram is shorter than the height of Stretchy's yellow tongue. Wow! So one parallelogram is actually shorter than my tongue. That's interesting. But why do the heights vary? Let's take a moment. Let's draw these right triangles over here. Okay, so if we look at all the right triangles that we just drew, do they look the same to you? Oh, no. This right triangle appears to look bigger than this right triangle. Exactly. That is the exact reason why a parallelogram's height can vary from tall to short. Because the height of the right triangles also varies. And the right triangles themselves, you guessed it, also vary. Wow! That's interesting! Yes. And what's also very interesting is that sometimes when you draw this side of the right triangle plus these sides, you could see a hidden trapezoid in there. Wow! 1, 2, 3, 4. 4 sides. This is a trapezoid. A trapezoid could be hidden in a parallelogram. That's very cool. Wow. Very cool indeed. Yes. Finding the area of a parallelogram should not be too tough. But what about if there are no vertices over the base? That might be pretty difficult. But you know what? It's actually quite simple. How? Oh, I get it. Stretchy, what are you doing? Just, mapping out the idea. Oh, yeah, okay. So, the parallelogram itself does not have any vertices over the base in this scenario. But if we look carefully here, there are two hidden triangles that could make a whole rectangle. This is 1 centimeter long, 2 centimeters this way, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 centimeters this way. The area of the rectangle is 22, because 11 times 2 is 22. But the area of the parallelogram is not 22, because the parallelogram is smaller than the rectangle, obviously. So, we need to do something else. After we find 22, we subtract 22 by the area of the two right triangles. 2 times 1/2 times 6 times 2. 6 times 2 is 12. Times 1/2 is 6. Times 2 is 12. 22 minus 12 is 10. Plus, we similarly subtract 11 times 2 minus 2 times 1/2 times 6 times 2, which also equals 10. So the area of the parallelogram is 10, not 22, not 12. The area is 10. Because you can't count diagonal centimeters. You need to count vertical and horizontal centimeters. So adding these triangles made the horizontal and vertical centimeters so that it's easier to count and find the area of. And that is very cool among what could be very awesome. Okay, well, that's it for us today. I hope you enjoyed the video. As always, stay curious. Keep solving math mysteries. Bye! Bye-bye! Hey, wait for me!